So now that we understand that cybersecurity is all about building processes, procedure, and systems around our asset to prevent it from unauthorized access. But when we say protecting our asset, what exactly are we referring to? Or what aspects of that asset are we really trying to protect? That is where CIA Triad comes into play. CIA Triad stands for confidentiality, integrity, and availability. It simply defines the aspects of an asset that we are trying to protect. So if there is a secure system, that secure system should be able to keep the CIA triad intact for that asset. Now let's try to understand confidentiality, integrity, and availability. Confidentiality simply means the data should remain confidential to unauthorized access. What it means is only authorized parties should be allowed to access that particular data. For example, let's say you have a confidential file which only you and your friend should be able to view and no one else. Okay? So that file should be confidential to the rest of the world other than you and your friend. Now, how do we do that? That is where encryption comes into play. Let's understand what is encryption. Encryption is the process of transforming plain text or a file into a string of characters using a secret key. What it means is, let's suppose you have this secret. Okay, this is a top secret. Now you will pass this secret through a mathematical function called encryption algorithm. This encryption algorithm will require you to supply a secret key to it. Okay. Once you pass this through the encryption algorithm and pass a secret key to it, it will output a jargon of text which would make no sense to anyone. Okay. This is called encrypted text. Now you will send this encrypted text to your friend. Okay. Now for your friend to be able to view this data from this encrypted text, he would need the same key. The same secret key which was used to encrypt this data will be used to decrypt this data. So if you want you and only your friend to be able to read this text, you guys would need to share this secret key. Okay. So let's understand types of encryption. Encryption is of two types, symmetric and asymmetric. Symmetric encryption means there is a single key which is used to encrypt and decrypt. This is how symmetric encryption looks like. There is a single key and this single key is shared between both the communicating parties. Okay. Asymmetric encryption. Asymmetric encryption is where a pair of keys is used to encrypt and decrypt the data. One key is private key, one key is public key. And as the name suggests, the private key remains private and the public key remains public. Let's have a look at this diagram. Let's say user A wants to send some data to user B, okay? And he doesn't want anyone else other than user B to be able to view that data. Now, how would he do that? User A will take this secret and pass it through the encryption algorithm. Now this encryption algorithm will be provided a public key of user B. So user A will provide the public key of user B to this encryption algorithm in order to produce this or in order to generate this encrypted text. Now the only person who can view this data is the one who has private key of user B. Now ideally user B should have the private key, right? He should have his own private key, obviously. Once he receives this encrypted data, he'll pass it through the decryption algorithm and pass his private key to it. Once he does that, it will give the plain text output and user B will be able to read that secret message. Integrity. By integrity, we mean the data should remain in its intended state, which means there should be no unauthorized changes made to that data. For example, let's say you create a file, right? And you save it on your system. Now, when you come back later on and you want to view that file, you need to make sure that there are no changes in that file, right? Only you as an authorized user should be able to make changes to that file. No person other than you should be able to make changes, right? So if someone else other than the rightful user is able to make changes to that data, then we'll say integrity is breached, right? So how do we achieve integrity, or how do we identify if a data has been tampered with or not? That is done through hashing. Oh, so what is hashing? Well, hashing is a one-way function that generates a fixed length output for any length of input. For example, I have these string of characters here. I'll pass it through this hashing algorithm, which is also a mathematical function, and it will generate a fixed length output. Okay. Now, one thing to notice is hashes, this is a hash. Hashes cannot be reversed. Okay. Unlike encryption, they cannot be reversed. So if I have this text capital ABC and this text where A is in lowercase ABC, it will generate an entirely different hash. For example, if I go to my terminal and I create this file test.txt, we can see we have capital A, lowercase b and lowercase c. Okay. Now if I calculate its hash, it comes out to be this particular string, right? But let's make some changes to this file. So we'll replace capital A with a lowercase a. And now let's calculate the MD5 sum for this file. As you can see, both these hashes are entirely different. So that is how we can identify or differentiate between a file which has stayed in its original state or a file which has been tampered with. A very simple example is file integrity check. For example, whenever a developer publishes a software, they also publish its hash on the website. Okay. So when you download that particular software, you can recalculate its hash on your side and then compare the calculated hash with the one which is posted by the developer. If those two hashes match, then it means it's the same file that the developer intended to serve. But if there is a difference between those two hashes, then it means there has been some changes in that file, or maybe the file is corrupted, or maybe someone made some changes to it. Okay. Availability. Availability simply means the data should be available as and when required. For example, as a banking app user, you would want to be able to do payments, receive payments, query different aspects of your bank account details anytime you want, right? So that is where we say availability is, that is where availability comes into picture. So how is availability achieved? It is achieved through data redundancy and load balancing. By data redundancy, we basically mean, let's say there is a single database, okay, where it stores all its users' data. Now, what if due to some reason that entire database's data is corrupted, right? Then the website will not be able to serve data to users. In that case, it is suggested to make different replicas of that database on different databases. So for example, even if one database is corrupted or it goes off, we have other copies of that database which can serve the user. Okay. And load balancing simply means, let's say a server is only able to process 10 requests at a time or 10 users at a time. But what if it receives 15 different requests, or let's say 15 different users, if it has to serve 15 different users when it only has the capacity of serving 10, what will happen in that case? In that case, the server will crash, right? And again, the website will not be able to serve data to its users. So in that case, there should be a load balancing mechanism which can simply redirect the extra load to different servers so that no single server is overwhelmed. So that is what CIA Triad is.